All right, here. So for the third lesson of chapter 13, we're going to look at a few ideas here. So let me start moving through. So the idea of a cardinal number of a set is simply how many elements are in the set, and that's the simplest way to look at it. When you get a set of information like this, there's two questions that they can ask you, and so it's really important that you're careful to understand what they're asking of you. So in the first question that they could ask you is to list the specific elements in the set. The other thing they can ask you is to find the number of elements in each set, which is just simply how many elements do you have. So in the first one, when they say list the elements within the set, right, you're actually listing the specific elements. If I gave you this equation to solve, and I were to say what are the values for x, well, we would know that to solve this equation, I would set each factor equal to 0. This factor would produce an x equals 1 as my answer. This one, if I set equal to 0, would give me x is negative 2 as my answer. And those are the specific elements of that set. And so we listed them. We always list them with braces whenever you list the elements of a set. The second part of the question, though, is the number of elements. And that just simply means how many. So in this case, there are 2 elements within that set. And that's all they want to know is the number of elements. So really careful to make sure you understand whether it's this concept where you're listing the specific elements or it's this concept where it's just the number of elements. So again, if we were to do that, say with the vowels in the word Hawaii, that's the description of the set. Well, if we were to list the specifics, right, list the vowels A, I, and I. So these would be the specific elements within the set. Oops, a little too many A's right there. So right there we listed the specific elements. So that's the response to the first part where it says list the elements. The second part then is the number of elements that are in the set. And we can see that there are 4 elements within that set. So again, just understand the 2 different types of the question that they can ask. Let me show you 2 more cases. So 3 and 4 are a little more, they're kind of more along the lines of like a special case scenario. But if we were to take a look at that expression right there, and they told me to list the elements within the set. So again, we want to do something like this to set it up, because we're going to make a list. Well, if you were to solve this equation, notice it does say that x is an element of the real number system, so I have to use real numbers to solve this. So if I said x squared plus 9 is 0, if I were to solve that, right, well, we would go to this step right here and square root both sides. Well, what's the square root of negative 9? Right, you can't do it. There are no 2 numbers that would multiply together to give you negative 9. Back in Algebra 2, you dealt with like imaginary numbers and things like that, but those are not a part of the real number system. So for these guys, there's a no solution case right here. So simply, if I were to list the elements, well, there are no elements that would satisfy that equation, so we leave the empty set. So the empty set is the way you want to respond to that. You can do this as well. Either notation is accepted. I would encourage you to go with this one though, but either one is considered correct. What you don't want to do is say 0, because 0 is the response to the next question, where if we were to say what are the number of elements within the set, well, the number of elements in set Z is 0. And so this is how you identify the elements within the set. This is how many elements are in the set. So just be careful on the way you respond to those questions. So last one right here. You'll notice in the cases that we've had so far, the list of elements was pretty small, and so it was easy to list the specific elements. But if you look at this last one, y is any real number, there's no way you can list all the elements within that set. And so when they say list the elements within the set, there's kind of a couple ways you can respond to that. One is to say, like, you can use some kind of like an inequality statement, or you can simply respond with words, because you can't list the specifics, so you have to give a general statement. You can literally say that y, just respond in words and just say y is all real numbers. and that would be accepted. So you just respond with words. If you can use like an inequality statement, we'll see some of those down the road. Those work too. Or you can simply respond with not possible, because it's not possible to list all the real numbers. So if I literally can't, because it's an infinite amount of values, then you just simply say it's not possible. As far as the number of elements within that set is infinite. That's a set that goes on forever, so there's an infinite amount of elements within that set. All right, so we're continuing on here into kind of the next section in your book, but it's still part of the same lesson here. So the difference between equal and equivalent sets is simply this. If sets are equal, then they have the same elements. So this has 1, 3, and 5. This has 1, 3, and 5. So those two sets are equal to each other because they have the same elements. Equivalent sets have the same amount of elements. So if they both have 4 elements or they both have 5 elements, then they would be equivalent. So in that case, they don't have to be the same elements. They just have to have the same amount. A couple symbols you should know for those. Really important for this chapter that you know the notation and the symbols. That's a big part of this chapter. You got to be familiar with those. So now we're getting into subsets, which is kind of the heart of the rest of this lesson. A subset is just a group within the group. So we showed this actually in the very first lesson of this chapter with a deck of cards, and we said that face cards are a subset of a deck of cards. It's a smaller group within a bigger group. It's a subset. So if B is a subset of set C, only if the elements in B are all in C. And so again, here's how we would write that, and this is the notation that you need to know for that. So this would say that B is a subset of C. If it's not a subset, then we draw the line through it, and that's another form of that notation. So let me give you a couple examples to go with this idea. So if you had set A, if it said list all the subsets of set A, so that means I can come up with any set that would include 3 and 4. So if I were to list all of these, we could say that three is a subset of set A. We could say that 4 is a subset of set A. We can actually say that the entire set is a subset of set A. So you can do what they call an equal set. So an equal set is considered a subset, as well as, and this is one people always forget, an empty set. So they would actually consider an empty set to be a subset of A. So when it comes to subsets, that goes from including everything to including nothing and everything in between. One thing you should know for this, just as a nice way of checking to know that you got all of them, is there's a little formula, and I wrote it down here if you kind of glance down towards the bottom of your notes. Right here, this is how many subsets are in a set. So to give you an example for the one that we just did, there are 2 elements within that set. So there are 2 to the 2 power, because there are 2 elements, so to power of 2. So there are 4 subsets of set A, and you can see that we did list all 4. So for example, let's just say you had 3 elements within that subset. Okay, I'm just going to make one up here. So let's just say I had 3 elements. Then there are 2 to the 3rd subsets, or 8 subsets. If you have a list of 3 items, there would be 8 subsets that you could come up with. It's a good thing to know you actually asked a couple questions just along those lines, so that's important to know. Moving down to example 2, a proper subset, and this is tough. People always kind of have a hard time remembering what is a subset and what is a proper subset. A proper subset is simply all of the subsets except for the equal set. An equal set is considered a subset of A. However, it is not considered a proper subset of A. So this is the only subset that is not proper. So when it comes to listing proper subsets, there is one less. There's one less amount of proper subsets than there are subsets, and that's because of the equal set. You can't include him. So if we had set A was 5 and 6, and I said list all the proper subsets, so look at all these guys. These are all of your subsets of A. The only one that is not proper is E. So in this case, choice E here is the only one that is not a proper subset of set A. As far as the notation for that, little C value that we showed up above here, this was the guy that represents a subset. If you take away the line, it's a proper subset. And so just to give you a couple examples here, as far as set C, we could say that C is a subset of A. We could also say that C is a proper subset of A. So both those statements would be true. We could say the same for D. D is a subset of A. It is also a proper subset of A. As far as E, E is a subset of A. However, it is not a proper subset of A because it is equal to A. So I can say that it's a subset, but I cannot say that it's a proper subset. F, again, is a subset of A, and it is also a proper subset of A. So those are all the things that you could say are true as far as the notation goes for that. Let me just tack on one last idea here on page 365 of your book. So there's a great chart on page 365 that helps show you some proper notations that are involved here. So let me give you one example. When you say, because we know that 5 is a subset of set A, we also know that 5 is an element of set A. So one idea with notation is when you list an element, so if I were to say that 5 is an element of set A, you'll notice that we do not put braces around the 5. However, if you say it is a subset of A, so if I were to say that 5 is a subset of A, or proper subset, then we do put braces around that guy. So this is just a difference with notation. You're going to run into some true-false questions along these lines that will come up on your test. People often get those wrong because they don't recognize which notation is appropriate. And so it's important that you know that when you're doing an element, you do not use braces, but when you're doing subsets or proper subsets, you do use the braces.